I'm going to talk about SQLBoiler today, and I kind of want people to ask themselves a question, and it's, do I need an ORM? And I'm going to show you a bunch of stuff, and at the end of the presentation, I want you to ask yourself that again, if you don't already use one, of course. So let's get started. So I'll just give you a quick brief on who I am. Why am I here talking? My name's Aaron Lefkowitz. I'm a real language geek. I'm into Haskell and Elm and all sorts of stuff, F-star. I really like languages. That's how I got into Go at the first place. I've been using Go since 1.0. I'm the author of SQLBoiler and Authboss. Authboss is a really useful library if you do web applications and you need authentication and forget me emails, password reset stuff. It's really useful. I've worked at Hewlett-Packard Enterprise and SUSE Linux, leading teams of Go programmers to work on stuff like Kubernetes and Docker products. It's all been very interesting. I don't work there anymore. Right now I'm working on my own sort of Bitcoin technology, and I'm learning to fly airplanes. So that's who I am. Let's talk about what we're going to talk about today. So we're going to look at some of the problems with not using an ORM. We're going to look at some of the solutions around that, including SQLBoiler. We're going to look at usage of SQLBoiler, relationships, which is a big part of what we do in SQLBoiler. We're going to look at some cool stuff that you can do with contexts, as requested by Clint, and have some Q&A at the end. So, problems. The Go standard library is good enough. Now, if you guys are involved in the Go community, you've heard this a number of times, especially around the HTTP stack. Most people will come on Reddit or the whatever forum and ask, well, what framework do I use? And the answer typically is, well, none, you don't need a framework. The standard library is perfect, just use it. And there's varying degrees of that, of course. I think that for SQL, the standard library is particularly painful, and we'll look into why I think that. So this code, I hope you guys could see that. Can anyone yell if you can see that perfectly?
Yep. Yes.
Awesome. So this code here does something extremely simple. It does one logical task. It grabs a bunch of users from the database where they are not deleted, soft deletion, you know. And the amount of code here is somewhat prohibitive. There's also 3 different errors that we have to handle. There's just a lot going on. And this is the typical thing. This is a simple select. Now, there's 2 problems here from an organizational and coding standpoint that become problematic. They're really subtle, but I want to ask the question if anyone knows what 2 problems I'm referring to. And it's not the errors thing, we talked about that. Problems, does anyone have one? It looks fine. Everything's great in this code, right?
Select star is terrible.
Flex, sure. Okay, that's a problem. But really, that part is a problem to me. So the fact that this string is in here is a problem in my eyes. And we'll get into why. Just remember this, the select string was a problem. The second problem that is here is a little bit even more subtle, and it has to do with the scan. And the scan is problematic for a reason you probably wouldn't normally think about. And we'll get into why in a second after we look at one more problem. So here's another problem. Here's another set of code. And at the start, we're simply execing some stuff, insert into users, a simple insert. And then we have all this code at the bottom. What do you suppose that this code is doing? Anyone?
Returning the insert you just did?
That's right. It's actually returning values from the database. And we'll see why I think this is the problem right here in a sec. So we said that query strings are a problem. Well, why are they a problem? It's just a string. What's wrong with that? Well, there's a few things wrong with it. First off, where do you put all this? This is an excerpt from code that I actually wrote in my beginning Go years when I was writing IRC bots just to try and learn the language. And this is some SQLite queries. And I couldn't figure out what to do with all this because they started getting littered all over my program. And I said, okay, well, maybe I'll make some functions to clean this up, but these things don't really format nicely inside a function just because of Go format and the way it works. It's just kind of an ugly way to store queries. And on top of that, they're strings. So what happens when I need to change something in the database? Well, now I got to go chase down all the references and hope that I get them all. Or if I forget, the worst part about this is there's no compiler support to detect the error. I have no idea that my database has changed underneath me, and now suddenly my program doesn't run correctly. It compiles fine, but it doesn't run. So that to me is a pretty big problem with this. And we'll see how we can address this later. So the scanning thing, well, what was wrong with the scanning? It's really difficult because you're probably going to have the impetus to create your own function to scan whatever, a user back out of the database. But the problem is when you try and create a select user function, you need to have the perfect list of scan arguments. What this means is that the Go standard library doesn't accept fewer or more pointers than you're supposed to be getting out of the database. It's a one-to-one mapping between columns and pointers. So the only natural answer is reflection. So now you have to write reflect code just to be able to get this list correct for a general purpose select user function. That's also kind of ugly. So the last one that we are looking at, we said that created at value came back out of the database. Well, this is a problem. These default values, this is a table here, this users table, which has an ID and it has money. Both of these things are created by the database if not provided. So when I insert a value, or sorry, insert a record into my database, I kind of want the Go struct that represents that database object to be updated automatically with the values that the database created. Because otherwise I'm out of sync, right? And now I start passing that object around, but it's got a money value of 0, where it should have a money value of 100. So we want to retrieve these values. And the awkward part is it's not even all the time. So again, if we're trying to create that general purpose function, did I pass in a value for money? I need to know that. I need to do an if statement on that and put either, remember that scan statement. If I did put money in, then I don't need to scan it. If I did, then I do need to scan it. So it's all over the place and it's not easy. So kind of the problem summary, these are simple problems, but they add up into what you'll probably have to face when you create your own data layer in Go with the standard library. The problems are, it's kind of verbose. The organization and maintenance of those query strings can be hard, and general purpose functions can be hard. They're not easy to write. They require reflect, and we haven't even touched on more advanced queries. This is just the basics. We just looked at one insert and one select. So already we're running into problems. So what can we do about it? So the very first thing that you're going to say is, well, just put all that stuff in a function. You know, you can do the reflect code and all this stuff. This is the natural evolution from just writing it in line, of course. But you'll find that every single table has the exact same function. The select looks exactly the same. So how do you start to reconcile that, especially in a language without generics? Do you write even more reflect? How do you do that? And then as soon as you do all of that extra reflect, you've lost all your compiler help for types being mismatched and whatnot. So it's kind of hard to write these for the generic case properly if you're going to use reflect again. The next option, everyone usually tells me in the Go community is, well, I don't need an ORM. I use SQLX. And this does help a lot. I used SQLX at the start myself. I think it's great. It gets rid of the binding problem, which is binding data to structs. Makes it really simple. However, it still doesn't help us with our query problems, and it doesn't really help the default value checking return problem that we described either. That also is unsolved by SQLX. So you need a bigger hammer. And then hammer, could it be an ORM? Well, we've got some pros. We have query building. And the cool things about query building is that you can use constants that break compilation when you go to compile, instead of just saying, hey, I'll just throw this string at the database and see if it works. You can actually use types that can break too. Say you're doing a where statement on the name of a user. You can actually enforce that where statement to take a name. And inline queries feel a little better when they're written in proper code rather than just magic strings everywhere. A cool thing about ORMs is they automatically create all these handwritten functions. It's dry, you know, do not repeat yourself. And the cons, well, the cons are that ORMs are the root of all evil. And there's probably quite a few people in this room who have used an ORM and just been baffled by whatever it's spitting out or the problems or the bugs that you find. And this can happen. It's happened to me. I was an avid active record user in Rails, and sometimes I just didn't know what. So the detractors will tell you ORMs are black magic. Query generation makes ugly queries, and that it can't possibly be performant, and it must use reflect, and it will add a lot of bloat to your project. Now, these are all sort of exaggerated arguments. Query generation, at least in SQLBoiler, pretty much makes really basic queries. It doesn't make huge, crazy queries. You can't actually do that, so you have to revert to writing queries yourself at some point anyway. And it can't possibly be performant. I think if you look at the benchmarks, the amount of overhead of SQLBoiler is extremely small. As always with database stuff, usually the performance problems are going to be in the database itself. It must use reflect. Yes, you've got me there. It will add a lot of bloat to my project. I think that this can be true, but if you look at the code that we generate in SQLBoiler, it basically looks pretty much like what you would have written yourself. So it's not that much bloat. And there's just a couple libraries, helper libraries that you include as a dependency on top. So I don't think it's that extreme to bring this into any even small project. I found a couple of things on Hackers News that I thought was interesting. It's an anti-pattern, ORM. The abstraction breaks down. Well, it's supposed to break down eventually when it can't deal with it. You know, Go is not SQL, just like LINQ is not SQL in C#. You cannot make an abstraction that will be all things that SQL is. It's just not possible. And so it eventually has to have some line that the ORM won't cross. And I found this one particularly funny. What ORMs have taught me, just learn SQL. Using an ORM is no excuse for not learning SQL. You should all know SQL if you're interacting with a database. Okay, so let's talk about SQLBoiler and how it solves these problems and all the things that you can do with it. So just a little bit about it. It's database first. So you start with a database. You don't, it doesn't define the schema, which I think is an incredibly bad idea, which I've gone into in other places. It's productive. You don't have to repeat yourself unless you feel like it. It still feels like Go, except we use a fluent interface. Some Go people have reservations about fluent interfaces, but for the most part, it's very Go-like. It's performant. We use caching in several layers, and we have a highly optimized binding, data binding system. So it's actually very, very fast. Again, check out the benchmarks. It's not really, performance really isn't a concern. Relationships, it does relationships very well. I think the only one that has anything better is GORM, which does polymorphism on top of the things that SQLBoiler does. But that's a simple thing to do in SQLBoiler if you need to. And the cool thing about SQLBoiler is it draws that line that we were talking about, where that abstraction breaks down. It's very easy to not use SQLBoiler, even if you're using it in other places in your project. You can just throw it out whenever you don't need it. It doesn't want to get in the way. What about these problems? We're looking at these problems. Here's that select statement that we're looking at. What does it look like in SQLBoiler? Well, it looks like this. What you do is you create a users query, models.users, and you qualify that with the where statement. And here we're using models.user columns.deleted, and that's a constant that's generated for you based on your schema. And when that schema changes, deleted that name, it either goes away or it changes. Your compile is going to fail. And this is leagues above having a string. Now I know what you're thinking. You're thinking, oh, that equals question mark thing. I don't like that. I've got actually some ideas on how to handle that and make it even better. Because as you see at the bottom of the slide, we don't have compiler check types yet. There are some ORMs that do in Go, but again, I think that I've got a solution for that. So we're working on it. And this code is a lot more terse, but it's also flexible. A lot more terse than the standard library version anyway. We're doing one logical thing here. We look up some users. We handle the error one time. So I think this is a big improvement. So what about the insert? Because we had that whole problem with the last insert ID and the second query and getting the data back. In SQLBoiler, that simply looks like this. So we create a user, just like a normal Go struct. There's nothing magical going on here. And then we say user.insert, and you'll see the boil.infer. That little thing tells it how to handle default values. It basically says, look at my struct and the values inside it, and decide what's best for what should be inserted into the database and what should be returned as a default value or an ID or whatever from the database. And if it's not necessary to do a second lookup, it just won't. So it's efficient in that sense as well. So default value lookup is handled. We also get automatic created at and update stuff. Fine-grained control over what fields are inserted. It says boil.infer here, but there are other values that you can pass in that spot to declare a whitelist or basically change the way the inference is working. And then again, regular Go struct creation, which I think is really important, because if your code stops looking like normal Go code, then I don't think it's worth it. So how does it do all this stuff? First off, there's database specific drivers. They're decoupled from SQLBoiler. You can write your own for whatever esoteric relational database you want. We had an individual contributor add CockroachDB for us, which was very cool. Code generation. And I like to say this about the code generation. It generates the methods that you would have made anyway. Basically, I took the things that I would have written and I put them in the default templates. And you'll see examples of those coming up. It has a library for query building. This is just so you can use those constants. So you can use Go code to produce those query strings instead of having to write the strings and manage that in some fashion. It does binding, functions to help bind SQL rows to structs and slices. This is basically what SQLX does. And just as an aside, you can actually use SQLBoiler instead of SQLX. It'll do the exact same job as long as you just only call bind. There's no difference really. Caching layers. So just to keep it fast, we do cache generated queries. We do cache struct bindings stuff. So it keeps it quick. Notes on code generation. A lot of people miss this. SQLBoiler for the most part is just a code generator. It's got output that's tweakable via config and command line. But the cool thing is the drivers are replaceable. Like I said, you can write your own driver for whatever. Templates are replaceable. And you don't just have to stick to Go files, which I think this is really a cool feature, because in projects that I'm creating, I'm using protocol buffers, I'm using gRPC, all these sorts of things. You can generate files for this based on your database structures. And a lot of the time, that's what you want to do when you're creating an API, maybe with some changes, but hopefully you can accomplish that via Go's templating language. It's just a very neat feature. So notes on code generation. So run it. I was going to show you guys this in my Linux terminal, except my Linux system froze up because of Zoom. So we get to look at the slides. I'm sorry. This is the database that we're going to work with for the examples that are coming up. You could think of this as a mini YouTube. We've got users, they've got profiles, we have videos that belong to users, and we have tags for those videos. Very straightforward. So how do you start with SQLBoiler? Now, most of these ORMs, like I said, want to define the database schema, which I don't think is a good idea. So have a database, that's the first step. And I recommend you use a migration tool to keep track of how your database evolves over time. So run your migrations, get it ready, and then create a config file that tells SQLBoiler how to talk to it. You install SQLBoiler in the driver, and then you're basically ready to do the generation. There's a getting started video that goes over all that stuff. So you can check that out if you're into video documentation. Otherwise, our README is, I don't know, like 3,000 lines long or something. Here's SQLBoiler.toml. This is the config file. There's nothing special about it. There's a bunch of values that you can include in here. They're all listed in the README. You can check that out. But for the typical case, you'll just have DB name, host, user, and pass. You don't even need port or schema in the normal cases. So once you have this SQLBoiler.toml, this is all you do. You just call SQLBoiler. I add the wipe in there as sort of like a default argument. It deletes the generated files from the previous run. That helps if in case you delete a table or rename a table, because it doesn't try and do diffs and guess which files should be there. It just overwrites what's there and leaves anything else just lying around. So anyway, SQLBoiler wipe PSQL. PSQL is the driver name that will actually find and execute a binary called SQLBoiler-PSQL on your system to talk to Postgres for it and get all the details that it needs to do the code generation. So what does it generate? It generates a whole bunch of stuff. It generates a users file. And I just wanted to show you guys what the user struct looks like and ask you, and say, kind of make a statement that it doesn't look too bad. There's nothing crazy in here. We have some struct tags. The only weird stuff is the R and L at the bottom. And these are sort of a necessary evil, but in pretty much every case, if you're not using them directly, you just ignore them and there's nothing to it. So int and string, really normal types. You just use them just like anything. If you use null int, null string from the SQL package, we have a null package that we developed ourselves that serializes JSON a lot better than the standard library versions of null string, null int. So you will get a different type that has a null flag. That's better than using pointers. Some ORMs say that you should use pointers to an ID or pointers to name, but that actually creates extra strain on the garbage collector's bad practice. I would not do that. So the other thing, like I just pulled the Go doc from what users.go kind of had in it relating to users. And you can see all of the basic things that you would probably have written yourself if you weren't using this ORM. You have delete, insert, reload, update, upsert, and you can find a user by an ID. You can check if a user by a certain ID exists. And you can do general queries on the users. That's the top one. And you can see it returns that user query, which I've highlighted because I just want to look at what a user query is. So user query, it's a little struct that embeds a normal query. And it just gives us a little bit of extra helpers on top to add the user part, those type safe functions like all, one, count, etc., that all have to do with users. So this is cool because when we say .all, we just get users back. We don't get interface or anything like that. Type safety, it's important. And what is a queries.query? What is that thing inside? That's just a basic query. It's basically something that can be rendered into a string and executed just like the standard library can. So even if you just wanted to use SQLBoiler's query generation, you can do that and just execute it like this. You notice bind at the top is one that they don't have. That allows you to, of course, bind to structs and slices. Well, let's look at some basic queries, what they look like in SQLBoiler, just to see. There's finding a user with the ID 42. The next one is looking up all users. Next one is looking up all users and selecting their name, limiting to 5 users. And users where name equals John. You notice that I'm using strings here. You can technically use strings. I only did it to fit it onto the slide. So you should use the constants because it actually provides benefit. And the last one is just inserting the user with a whitelist, which says only insert name. Don't insert any of the other columns. Assume their default values, and you need to return those for me. So these are basic queries. Okay, I realize I'm going very fast. Any questions up until this point? We're about to dive a little bit deeper. Good. Okay, so relationships. I wanted to put a section on relationships because I think they're important. You note that PostgreSQL is an RDBMS, if you remember this acronym from your schooling, probably, a relational database management system. It's a mouthful, but the relational part is really important, and it's really important in my opinion, that ORMs take care of this for us. And a lot of people are going to other types of databases now, but I don't believe relational databases are going anywhere in the near future. They have a really good use case. There's object databases, there's graph databases, there's KV, there's time series. And all of these have other applications. But for your standard shopping cart website, you're still going to reach for MySQL or Postgres or whatever. And again, relationships are important because without related data, we would really just have one giant table with a bunch of arrays in it. And that doesn't work really well for performance. And like I said, ORMs should really help with this. So this is the first kind of simple thing that you can do with a relationship. You can interjoin some data in and filter based on that. So here we're finding videos which have users that only have a length or that have a name that's greater than 2 length. Why would we do this? I'm not sure, but there's the interjoin. That's how you would do it. And again, it's the strings to fit on the slide. Sorry about that. Here's a different one. This one actually returns the data because in the previous one, you didn't return the data. You were just returning the videos, but the user data wasn't pulled back at all. It was just used in the query. But here we get a tag, we get the first tag in the database, and then we get 5 of its videos. And I think that this syntax is really nice. It's an easy way to get the relationship objects from any sort of database object that you got back from a previous query. So I think this is very nice. And of course, like you see the qm.limit there, that is a query, so you can build it up however you'd like. The next ones, I call these relationship set operations. So if you think of your database relationship as a set, then you can do 3 different things to that set. You can add things, you can set it, which basically sets it equal to, and you can remove things. So here, we're able to add videos to this tag, set videos on the tag, which again will just make it so vid, in this particular case, is the only video that is associated with this tag. And you can remove vid from that tag's videos. So these are all really useful. These are actually big queries that you would have to write yourself. They're kind of annoying, so very nice that this helps you. And you'll notice that set videos and add videos take a Boolean flag. They can actually also additionally insert whatever you're passing in. So the add videos will actually insert vid into the database before it relates it. And I believe it tries to do that as efficiently as possible. So you only do one query if one query is possible. And you'll notice at the bottom of the slide, these are only generated when these operations are actually possible, which means that based on your relationship type, you may not be able to remove videos. You may not be able to add them, in a one-to-one situation or a non-null situation. Some of these won't exist. Okay, so on to one of the famous ORM problems, the n+1 problem. Now, of course, you can do this in the standard library as well. You can do it with anything, but in particular, ORMs try and solve this problem. Does anyone know how many queries this code would produce if we had 100 videos?
101.
101, perfect answer. So what happens is you select the videos, you range through the loop, and for every single video, you're doing another user lookup. Now in Go, that one user lookup relates to 2 round trips to the database, one to prepare the statement, which is a normal thing that it does for every query, and one to actually execute that statement and bring the data back. So basically you have 202 round trips to the database. This is not efficient. This is the anti-efficiency. So ORMs need to solve this problem in their way so that you can still use the types and whatnot that it carries with it. And so in SQLBoiler, we made this, I think, very, very nice. All you do is you make a query and you say qm.load and you give it the relationships. Note, we also have constant names for the relationships, which is basically where your foreign keys are, relating to different tables. So here, the video relationships.user is what we're putting into the qm.load, and that tells it to pull back the user. So this query only does 2. basically it does one select from videos, then it grabs all of the videos and it says, okay, for all of these videos, give me the users for them. So it does it very efficiently, 2 queries instead of 202, or sorry, 101. And you might be wondering, well, where did my data go? I asked for the user, how do I access that? And it's simply that R struct that we saw earlier. I said it was a necessary evil. I think that this makes it quite easy to access the relation or the related models after you've done an eager loaded sort of thing. So a little bit further on eager loading, we have nested eager loading. So I've done it without the constants, just so you can see it's a little bit simpler there. qm.load user.profile, that brings in the user's profile as well as the user. So I could do vids index1.user.profile and be able to access that all in one query, which is, or one statement rather, which is really nice. The constant version is below, so you can see we use qm.rels to basically strings join on dot. That's it. It's nothing fancy or special. And the last thing that we just put into version 3 of SQLBoiler was conditional eager loading, where you can actually decide for each level or each query that you're going to make to the database, you want to additionally say, you know, qm.where or limit or whatever you want to do there. You can adjust that query as needed. So raw queries, I told you guys that there's an abstraction layer that eventually needs to break. It just has to. Eventually you're going to find something and go, well, SQLBoiler can't do this for me. It can't query build it. It can't bind to it correctly or whatever. And you're going to have to reach out to raw queries. It's inevitable and intentional and designed that way. So we're going to start with the most SQLBoiler looking one, the most well done one, as I put it. We have a query here. We have some arguments. And the way we do a raw query in this sense, we're going to say models.users. We're creating a user's query just like before. And we're going to pass in qm.raw, which says, I don't care about your query building, just use this. But still I'm returning users. And still I'm using the .all helper. So I don't have to do anything past that. This is a raw query and it'll just bind to users for me. It's very simple. If you want to go a little bit further, we can use the queries.raw. This creates that queries.query structure that we saw before. And then we're going to call bind on that to bind to a data structure that I've created. This is actually important when you're doing, say, big inner joins and you want all the data back, because there's no such thing as a, you know, tags video struct that SQLBoiler generates for you. You would have to create that struct yourself and then bind appropriately. And there's documentation on bind on how to make that happen. And then the rawest of the raw queries is where you only use bind. Like I said, this is very SQLX. So you see, we've got models.user. We have to create our own data structure. Query context. Query context is just the normal standard library way of doing things, right? So you're actually executing that query without SQLBoiler being involved at all. And at the very end, queries.bind. We take that data, we shove it into my users, and we actually have to remember to close the results set, even though it'll probably be implicitly closed. It's our responsibility to ensure that that memory is freed. So that's the raw queries. This is how SQLBoiler can get out of your way when you don't need it, which I think is very useful. Okay, wow, we're ripping through this very fast. Context. So Clint asked to see a little bit on context. We do context support. We cooked it into all of our templates and whatnot. You can turn it off if you don't need it, but I recommend you leave it on and just pass context.todo or context.background in your web application or whatever you have. And that way you're prepared later for when you do want context, you don't have to go and change all your SQLBoiler code. I think we're one of very few ORMs that support context at this juncture. And also importantly, not every database driver is supporting context very well. For example, the Go MySQL driver is still quite behind on its ability to cancel queries and whatnot. So it's food for thought. I've written a basic program here. And the whole point of this program was just to demonstrate that we could cancel a request that's no longer necessary. And I made this simple so we can see what's going on very easily. So we create the with cancel context, which allows us to cancel it by calling the function cancel. Cancel is a function that stops the context, basically. And then we say models.users.all. That's just the basic select star from users, right? And the print line is showing us the errors. So if there was an error trying to do that query, it would be reported. Now, interestingly enough, the go statement there in front of cancel produces somewhat of a race condition. Sometimes the go runtime is going to be fast enough to execute the cancel function before the users.all, and sometimes it will choose not to. So there's somewhat a race condition in this program. So sometimes when I ran this, it would say PQ canceling statement due to user request. In this case, it was all the way down in the database driver talking to Postgres, and it canceled the request, hopefully freed the resources on Postgres send. MySQL doesn't do that yet. And then returns an error from the query. Sometimes context canceled was the error message. And what this is, it's a higher level error message, and it happens if the context has been canceled before we even started the query. So that's a quick return. And sometimes it just worked. And it works more often than not because just the way the Go runtime works, that Go routine typically won't start very quickly. So you get a lot of, had to run this a couple hundred times to get these error messages. But anyway, that's an easy way to do cancellation. With SQLBoiler, you can save your database resources. This is really important in scenarios where maybe you have multiple backends or something like Google does for their searching, right? Google sends multiple servers the same query and just returns whichever one's faster and then cancels the context of the rest of them. Cool stuff. And I also wanted to do another one, which I find is really cool, is benchmarking and tracing. So like any program, you really need to know that your web application is healthy and doing well. And sometimes you need to introspect it. And tracing is a cool way to do that. Now, I actually had never heard of this stuff before. This is the first time I've looked at it. So take it with a grain of salt. OpenCensus.io, I used that for this demo. And so what it does is it creates a wrapper around the Postgres driver. That's what that OCSQL.register is all about. And I say, with all trace options, just show me everything, give me everything. I apply some configurations and register an exporter, which is how it is supposed to dump the data. And they had all sorts of exporters that were cool. I can't remember a single one now. Prometheus was one of them, for example. If you wanted to export your traces and metrics to Prometheus, seems to be really easy. I wrote my own custom exporter because I just wanted standard out. In the end, we do SQL open just like we would normally do. We just change the driver name. So the driver name comes from that osql.register command. It probably does something like osql or whatever .postgres as a new driver name. The rest of the code looks like this. So I call this trace.startSpan, and I give it a name. And then I just end the span when I'm done calling whatever it was that I was going to do. So the context that comes back from trace.startSpan, I use that in all my database calls, and that's how I introspect this stuff. And I do the same thing for the models.users.all call. This is what came back from it. So you can see that ping took 1.85 milliseconds, and the select star from users actually came back in 440 microseconds. And there's an interesting explanation about that, which is when you start up a Go program and you connect to the database, there is no connection made when you call sql.open. It in fact creates a connection pool with no connections in it. And when ping is called, it's actually establishing that connection, which is why you get this slowness. On top of that, I kind of ran this program a couple of times, so the select star users was already cached by Postgres. Takes a lot longer if you restart the database. But the cool thing about this is you can see the various steps that it took to be able to get me that data back. You see the query, you see the rows next calls, you see the rows closed, and this gives you a better idea of what's happening in your database, and particularly the performance associated with that. So tracing, really useful. You can This can help you in a HTTP request trace all the way from the top of the HTTP request all the way to the nitty-gritty inside the database. So very cool stuff. And actually, that is all I've got. So like I said, I wanted you all to ask yourself the question if you needed an ORM or not. So if you find yourself coming to the same conclusions as I did, which is, hey, I'm writing all these functions and they all kind of look the same, and my SQL query strings are scattered all over the place, then maybe you should try out SQLBoiler. It might be to your benefit. And that's it. Thanks for listening, guys.
Are you considering adding open census right into SQLBoiler or no?
Yeah, actually, that is, there was a user that I believe from China. There's a bunch of Chinese gophers out there, a lot of them actually. One of our Chinese users mentioned that he would like to add something similar for performance tracking right out of the gate in SQLBoiler. Somewhat like Active Record. When you do a debug mode on that, it tells you how long each query is taking. It's a really nice feature. Totally up for that. I don't think I have time right now to implement that, but I would be super happy if someone wanted to work on that with me.
We can find someone.
Oh, any questions, anyone?
I can't really see you. I think you can only see like right here, right, Aaron?
Yeah, I've only got the little front of the room there.
I'll send you a picture, but you got a lot of people here.
Right on.
Yeah.
Have you done anything connecting gRPC field masking to SQLBoiler?
So I missed the middle part of that. I heard gRPC and SQLBoiler.
gRPC field mapping. Field masking.
Oh no, we don't actually. That's interesting. Nope, not yet. But it's something like all of this stuff is stuff I'd be happy to add, especially in the realm of like protocol buffer and gRPC support. I want that stuff to work really awesome with SQLBoiler because that's what I use it for. So, you know, if you have ideas about that, open a GitHub issue and we'll talk about it.
So do you mean like generating gRPC service definition and generating the code around it as well based on the database, or what is that? What are you
I think that's what Aaron's talking about doing.
Yeah.
But
Yeah.
use field
I'm talking
masking.
field masking, like, you know, based on the gRPC field mask, you only request X columns.
Oh.
Yeah. So you're talking about trying to keep some columns in the database private. Is that it? Sort of not sending them to gRPC sort of thing?
Not necessarily private, it's just for, it's kind of like GraphQL, you can choose which fields you want.
Yeah, so not returning all the rows or all the columns.
Yeah, I don't know. I haven't really thought about that in depth yet, but something to consider.
Any other questions? Okay. Well, thank you again, Aaron. Let's give him one more round of applause.
All right.